This is fundamental problem 7 from chapter 17. The 100 kilogram wheel has a radius of gyration about its center, O, of 500 millimeters. If the wheel starts from rest, determine its angular velocity in 3 seconds. So we're given the radius of the wheel, and we also have a force P, which is equal to 100 newtons. And for this, we are going to use this equation where we have the sum of the moments about point O is equal to the moment of inertia about point O times the angular acceleration. So in order to use that, we have to find the angular acceleration. We were given the radius of gyration, so we're going to use equation 17-5 to find the moment of inertia about point O, which is equal to the mass times the radius of gyration about point O squared. So the mass is 100 kilograms. The radius of gyration is 0.5 meters. We square that, multiply them, and we get 25 kilograms times meters squared. So now that I know the moment of inertia about point O, I can use this equation here. I have the sum of the moments about point O is equal to the moment of inertia about point O times the angular acceleration. I have one force which is being applied at a distance of 0.6 meters from point O here. So the sum of the moments is equal to that 100 Newton force times the 0.6 meters, but that causes rotation in the negative k-hat direction. So this is negative, and this is equal to the moment of inertia about point O times the angular acceleration. So I can solve this for the angular acceleration, and I get 100 times 0.6 is 60, so that's negative 60 newtons times meters divided by 25 kilograms times meters squared. Remember, a newton is a kilogram times a meter per second squared, so the units here are 1 over second squared. Negative 60 divided by 25 is negative 2.4, and then I can put in radians for the units to get 2.4 radians per second squared. So because the angular acceleration is negative, it just means it's this way. Okay, now I want to find the angular velocity when t is equal to 3 seconds, and the angular velocity when t is equal to 0 is 0. So my angular acceleration is constant, and so I can go back to the equations that I had for constant acceleration here. Well, actually, I could use equation 16-2, and I can say angular acceleration is equal to change in velocity over change in time. Therefore, change in angular acceleration, or change in angular velocity, is equal to angular acceleration times change in time. The change in angular acceleration is the angular velocity at 3 seconds minus the angular velocity when time is equal to 0, which is 0. So this gives us the angular velocity when t is equal to 3 seconds, which is what we're looking for since you're just subtracting 0 from that. The angular acceleration is negative 2.4 radians per second squared. Delta t, we're going from 0 to 3 seconds, so this is times 3 seconds. And that gives us negative 7.2 radians per second for our angular velocity when t is equal to 3 seconds. And again, it's negative because the rotation is in the clockwise direction. And that's our answer for fundamental problem 7.